In this tutorial, I am going to demonstrate how VLANs and Trunks works using Cisco Packet Tracer. For the purpose of this lab, I am going to use 3 Cisco 3560 switches and 8 PCs. So I already have 3 switches placed here. I need to create one more PC. So I left that for demonstration purpose, including the interconnect between these switches. So let me complete the entire network topology now. So to place a PC, go to the end devices, pick the PC, and place it here. To connect it, go to the connections and pick the straight through cable, pick fast Ethernet 0 and pick port 102. For this one, go to here, automatically choose connection type. Okay, it automatically chose the connection type and the port, but I'm going to go and modify the port to the gig port, gig 02, and I will do the same here, gig 02. So now the topology is complete. I have to configure the IP here. So this is a marketing PC. So let's do copy here, copy, paste it here, and then I go here, go to the desktop, IP configuration, 6, tab key, it will fill the subnet mask, close it out. So now you are all set. If you look at the switches and connected ports, they are all in VLAN 1, which is the default VLAN that comes with Cisco switches. So let's look at here. Put the mouse on top of the switch. You can see all of your devices are in VLAN 1, and same here and here also they are on VLAN 1. You can go to a switch, go to the CLI, show VLAN, and maximize it. You can see all the ports, including the interconnect port between the switches, that is the gig port, are on VLAN 1. Since they all in the same local area network or LAN and on the same IP subnet, they all can talk to each other without the problem. So let's open the command prompt and do a ping and make sure they all can communicate with each other. So let's go to this PC and open the command prompt and let me ping. So this is 101, let me ping 104. I'm able to ping 104. So 104 is this PC. So I am going, my traffic is going from here to this one. So it is crossing this interconnect link. And let me ping 107. I can ping 107. So all of them has connection between each other on VLAN 1. However, in an actual network settings, we don't put all the network devices in just one VLAN. You will have multiple VLANs for different purposes. For example, in an office settings, you will have multiple departments such as sales, marketing, accounting, etc. The best networking practice is to create separate VLANs for each department or purpose to improve security and traffic management. Let me elaborate this a little further. One VLAN equals to one broadcast domain. That means all the devices in one VLAN can see traffic belongs to that VLAN. Therefore, if you put hundreds of devices in one VLAN, broadcast traffic will be flooded in that VLAN and consume more bandwidth and therefore slow down the network. Also, it is not good for the security purpose, putting all the devices in one VLAN and they can see traffic from each other. When it comes to VLAN 1, You normally don't use VLAN 1 for your data traffic for security reasons. However, by default, all the ports belongs to VLAN 1. Since we are not going to use VLAN 1 for any of our data management purpose, so let's create separate VLAN for sales, marketing, and accounting. I already have created those VLANs in these switches. So if you see here, I created sales, marketing, accounting. And I have created the same here also. Enable, show VLAN. You see, I have created them. I yet to have created on this switch. Go to the CLI. Now, enable, show VLAN. And if you see, I don't have those VLANs yet. Okay, so do conf VLAN 10, name sales, VLAN 20, name marketing, VLAN 30, name accounting. So I have all the VLANs now. Show VLAN. I have all these 3 VLANs now. When you create different VLANs, you need to differentiate those VLANs with different IP subnet. So what I have to do is, I have to, if you see here, VLAN 10 is this subnet, VLAN 20 is this one, VLAN 30 is this subnet. So I have to go to the PCs and change those IPs accordingly. So I have to go to the marketing and change that to from 1 to 2. Okay, and then I go to accounting and I'm going to change that to 3. So I'm going to do the same thing for all of them. Now I changed all the PCs IP address based on the VLAN and subnet they belongs to. Now I have to go to the switches and change the VLANs accordingly. So if it is sales, I need to change them to VLAN 10. If it is marketing, 20, accounting, VLAN 30. So let me change them all. So I'm going to do this first. Enable 20 int. This is FA01. And then let me change that to switchboard access VLAN 10. So it says interface VLAN change to VLAN 10. And then I'm going to do the same thing for, that is 2, VLAN 20, int, that is 3, this is 3, VLAN 30. So I'm going to go and do the same thing to all of them now. All of them now have been changed. If you look at here, show VLAN. You see 1, 2, 3, they are on the right VLANs now. So it's going to be the same on the other switches. So let's ping this PC from this PC because they are all on same sales VLAN. Okay, let's go there. And this PC is 102, 102. I'm not able to ping. See whether I can ping the one in here, 101. I am not able to ping 101. The main reason is, here is where the trunking comes into play. If you look at here, this port is still on VLAN 1. Show VLAN. And if you look at here, these gig ports are still on VLAN 1. So it is not going to send a traffic that belongs to VLAN 10, 20, 30. So what you have to do is you have to make this switch interconnect port into trunk. So by default, the trunk ports can carry all the VLANs across the switches. So let's configure these ports into trunk. 20 int gig, there is 0, 1. Let's do this command. You can configure both commands. Copy from here, paste. Okay, so you can copy and paste multiple commands at the same time. So now it became as a trunk port. So go here and do the same thing. 0, 1, paste. Now it's a trunk port. So let's configure this also at the same time. 20 int gig 0, 2. That's trunk. And here also you have to do into 0, 2. 0, 2. Paste. So to make this side also a trunk. So now all of them are trunk ports. So let's go here and ping again this 101 PC. So this is 100, 101. You see, now I am able to ping because the link, the trunk link, can take all the VLAN across this link. If you look at here, show int trunk, you see this port big O1, VLAN allowed on trunk 1 to 105. All the VLANs are allowed, and right now the VLANs are forwarding on these trunks are VLAN 1, 10, 20, and 30. And now you should be able to ping 102 also. And prompt 102, yes, you are able to ping now. And go to here and then ping other two marketing PCs. Command, there is 2, 101, you are able to ping. This marketing PC 2101 is here, so you are pinging from this one to this one, and you ping the other marketing PC that is here 102, you are able to ping that one too, and go to accounting PC, ping 192, 168, 1. That is 3, 101, you can ping. I think I have only two accounting PC, 100, 3100, 3101. So now all these VLANs are able to communicate between each other using these trunk links. So this is how trunking works. So now let's define what is VLAN and see that makes sense. The virtual local area network, that is VLAN, is a logical grouping of network devices that appears to be on the same LAN despite their geographical distribution or geographical location. Think about this switch is in building 1, this switch is in building 2, this switch is in building 10. But you have marketing PC on all these buildings. So how you are interconnecting these marketing PCs are using the VLANs. So VLAN is a virtual thing. So that's why it is called virtual LAN. So when you talk about LAN, we are just talking about one VLAN, one broadcast domain. And when we talk about VLANs, we are talking about multiple LANs spread across multiple geographical location and switches. Hope this video is helpful for you. Please do subscribe and like this video and comment on this video and let me know what video you want to see next. Thanks. Bye.